Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. This is the seventh, I think, the seventh video in a series of chain rule videos I've done. The last two or three cover trig functions exclusively. The first ones don't. The trig is mixed in a little bit in the first ones, but anyway, before I go any further, I just want to review the trig function derivatives. The derivative of sine is cosine. The derivative of cosine is negative sine. Derivative of tangent is secant squared. The derivative of secant is secant theta times tangent theta. The derivative of cosecant theta is negative cosecant theta times cotangent theta. And finally, the derivative of cotangent theta is negative cosecant squared theta. So I just wanted to show you those first. Let's go back to our problem. Here we have a little product rule, and I want to review that now. The product rule, we have the two pieces here. This is our f of x, and this is our g of x function. So if I take this, the product rule, let me just write out those words here. Product rule, okay, where we have f of x times g of x. We're going to take the derivative of the first piece, which is f prime x, and multiply it by the second, which is g of x. And we're going to add the derivative of the second piece, which is g prime of x, times the first, which is f of x. So again, to differentiate using the product rule, and here's our two pieces, f of x and g of x. We're going to take the derivative of the first piece, which is f prime x, and multiply it by the second term, which is g of x, plus we're going to add the derivative of the second term, which is g prime x, times the first term, which is f of x. Okay, so we have product rule and chain rule going on in this problem. So let's go back to our problem. So, let's start working out the derivative. The derivative of sine 2 of x is a little chain rule problem. So the derivative of sine is cosine. And then we're going to multiply that by the derivative of 2x, which is just 2. I just put that in here. And then so the derivative of the first part times the second. So now we're going to multiply this by cosine 2x. We're going to add on the reverse piece. We're going to take the derivative of cosine 2x. So the derivative of cosine 2x is negative sine 2x times the derivative of the 2x, which is 2. And so that takes care of the derivative of the second part, and we multiply it by the first part, which is sine 2 of x. 2x, sorry, not 2 of x. Okay, so let's move ahead. F prime x is equal to, I want to clean up down here, and up here we can, 2 cosine 2x times cosine 2x is 2 cosine squared 2x plus, well, 2, actually, it should be minus, we have the minus sign at 2x over here, so let's put minus 2 times sine squared 2x. Because we have sine 2x times negative sine 2x, which is negative sine squared 2x, and the 2 is in here. So, okay, we're getting there. So, f prime of x, the first derivative, is 2 cosine squared 2x minus 2 sine squared 2x. Okay, now, we can't leave it in this format. This is the derivative, okay? This is the derivative I don't know if your professor would consider this to be an acceptable solution to the question, what is the derivative of this function? And here's why. Let me move this out. You probably recall from your trig class back in high school or junior high school, wherever you took it, that there's half-angle formulas and identities and all kinds of different formulas we use in trig to reduce or to simplify trig functions. And one group of these functions is the group called the power reducing formulas, okay? Now, sine squared u. Now, u is just any function. In this case, u is 2x. If we go back to this, let's go down here. We're looking for sine squared u. Well, this is sine squared 2x. U is equal to 2x. So sine squared u, this can be rewritten as 1 minus cosine 2u over 2. And something similar for cosine squared u is 1 plus cosine 2u over 2. So, we use these so frequently, and they're pretty easy to remember most of the time. And so for that reason, you should be expected to know this. So, okay, so we're going to do a little substitution here. And we're going to use our power-reducing formulas. In fact, let me copy this back down onto here. Let's take, so f prime x is equal to 2 cosine squared 2x minus 2 sine squared 2x. We're going to use the power reducing formulas, and these formulas, let's see, sine squared u is equal to 1 minus cosine 2u over 2, and cosine squared u is equal to 1 plus cosine 2u over 2. Okay, we're getting there. We can move this guy out of the way. Now, let's move forward. So we've got now, let me draw a little line. We have f prime x is equal to now 2 times, well, the first part of this thing is cosine squared 2x, and we're going to let u equal 2x. So we have 2 times 1 plus, well, u, it's 2u, and u is equal to 2x, so it's 2 times 2x, which is 4x over 2. And then we're going to subtract off 2, as if you look up here, it's 2 sine squared 2x. So sine squared u is equal to 1 minus cosine 2u over 2. So it's 1 minus cosine 4x over 2. Right? 4x because u is 2x, so 2u is 2 times 2x, or 4x. Let's move this up. The 2's are going to cancel on each of these. So f prime x is equal to 1 plus 4x minus 1 minus cosine 4x is plus cosine 4x. Therefore, f prime x is equal to, well, the 1 and the minus 1 go out. You know, this should be cosine 4x over here. Sorry, I kind of messed that up. 1 plus cosine 4x. So it's cosine 4x plus cosine 4x. So f prime x is equal to 2 times cosine 4x. And this is the elegant solution. This was the original solution we came up with. We used the power-reducing trig formulas to bring us down to this point. And this, I think you'll agree with me, is a much more elegant solution, derivative solution, to the original problem. And here's the original problem. Sine 2x times cosine 2x, f of x equals that. So, okay, so this was one trig problem. I'm going to make one more video. It has a very interesting problem involving cotangents and tangents and sines and cosecants and so forth. And that's going to take up a fair amount of time on the video. So for now, I'm going to end this one. This is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. This is the 7th video on the chain rule. I will have one final video, video number 8. And again, it'll be a chain rule problem involving a trig function. I hope you find the videos helpful. And take a look at all the math and economics and finance and investment theory videos that I have up on the internet. Be well, be happy, bye-bye.